Hello, so this is a revision video for AP Chemistry 2.6, Resonance and Formal Charge. This is a revision video, which means only the essential information is covered. For deeper explanations and full video lessons, please check the links in the description below and visit chemistrystudent.com. Resonance occurs when two or more valid Lewis structures can be drawn for a molecule by moving electrons only, never the atoms. These are called resonance structures. For example, when drawing a Lewis diagram for the molecule ozone, O3, we end up with two valid structures. If we label each oxygen as A, B, and C, we can see that in the first structure we have a double bond between the oxygen A and B and a single bond between oxygen B and C. And in the second possible Lewis structure, we have a single bond between oxygen A and B and a double bond between oxygen B and C. Now, neither of these is actually strictly speaking correct. The true structure of ozone will be a resonance hybrid, where we have an intermediate bond somewhere between a single and a double bond between both oxygen atoms. And we know this is true because when we actually study the bond lengths in ozone, we only find it has one oxygen-oxygen bond length, whereby if it had a double and a single bond, we would expect two different bond lengths. We see something similar with a carbonate ion. CO₃² can be represented with having a double bond between oxygen A and the carbon, a double bond between oxygen B and the carbon, or a double bond between oxygen C and the carbon, with all the other oxygens having single bonds. Again, none of these is actually the correct true structure, and instead the resonance hybrid will be an average of all three, all the oxygen-carbon bond lengths actually being the same. Now, sometimes molecules or ions may have more than one Lewis structure, but some are more valid than others. To determine which is the most valid Lewis structure or most likely, we can use something called formal charge. The formal charge of an atom in the Lewis structure is a hypothetical charge that we assign to an atom in a molecule. We assume that the electrons in all covalent bonds are shared equally between the atoms. To calculate the formal charge of an atom, we take the number of valence electrons it had at the start, subtract the number of non-bonding electrons it has in the Lewis structure, then minus half the number of bonding electrons it shares with other atoms. A preferred Lewis structure will always have the smallest possible formal charges on the atoms, and it will try and avoid the same charges on atoms next to each other. Ideally, more electronegative atoms have a negative formal charge, and the total charge of all formal charges should give the overall charge of the molecule or ion. Because of this, we can determine which is the most accurate Lewis structure for a particular species by looking at the formal charges assigned to each atom in it. For example, if we take an NO2 molecule, we can see there are two ways we can represent this as a Lewis structure. In the first, we can have single bonds between the oxygen and nitrogen, with one lone electron on the nitrogen atom, and in the second, we can have a double bond between an oxygen and the nitrogen, and a single bond between the other oxygen and the nitrogen. Again, the nitrogen has a single unpaired electron. How can we determine which is the best representation? Well, let's look at the formal charges. In the first structure, the nitrogen formal charge will be 5 minus 1 minus 4 divided by 2. Because the valence number of electrons for the nitrogen is 5, because it's in group 5, it has one non-bonding electron, and there are 4 bonding electrons around it, meaning 5 minus 1 minus 4 divided by 2, giving a formal charge of positive 2. The oxygens are both identical here in terms of their electron arrangement, and their formal charge will be 6 minus 2 divided by 2. Because their valency is 6, they have 6 outer electrons to start with, they each have 6 non-bonding electrons, and they each share 2 bonding electrons with the nitrogen, giving a formal charge of minus 1. So in the first structure, we have a positive 2 formal charge on the nitrogen, and we have a negative 1 formal charge on each oxygen. In the second structure, the formal charge of the nitrogen is going to be 5 minus 1 minus 6 divided by 2, because again, the valency of nitrogen is 5 outer electrons to start with. It again has one non-bonding electron, but this time has 6 bonding electrons around it. So therefore, 5 minus 1 minus 6 divided by 2 equals 1. However, in this structure, the two oxygens are different. In the first oxygen, the formal charge is going to be 6 minus 4 divided by 2. Again, a valency of 6, 4 non-bonding electrons and 4 bonding electrons. This gives a formal charge of 0. In the other oxygen, we have 6 minus 2 divided by 2. Again, a valency of 6 non-bonding electrons this time, and 2 bonding electrons, given a formal charge of -1. So which of these structures is better? Well, structure B only gives 2 atoms with a formal charge, whereas structure 1 gives 3 atoms with a formal charge, and the formal charges are also larger in structure A compared to structure B, meaning we've minimized formal charge in the second structure compared to the first, so the second structure B is a better representation. However, remember, it is still only a representation. It isn't a perfect reflection of bonding. As useful as Lewis structures and formal charges are, it's very important to remember that they do have limitations.